All right, let's go ahead and get started, everyone. My name is Milas. I'm a software engineer here at Docker. I'm on the Compose team, one of the Compose maintainers. And today we're going to talk about deciding between volumes, bind mounts, and Compose watch. You might have noticed the word Compose has already appeared 3 times in the past 30 seconds, and so you'll see it some more. This is not a which is better than the other, because really none of them are better than the other. They're all really cool parts of the Moby and Compose ecosystem here, but they all have different uses, and it can be confusing between them, especially with the introduction of Compose Watch, where we've heard a lot of feedback from people asking, well, how is this different from a bind mount? Why would I use this instead of a bind mount? And if you're not totally sure what a bind mount is, or a volume, or Compose Watch, don't worry, you're in the right place. So let's look at bind mounts first. So what is a bind mount? A bind mount exposes a host file or directory. So really this is kind of a way of, with containers, we think of everything as sandboxed or isolated by default. When you look in the container has its own view of the world. It doesn't see the host's view. It's nice and it gets to pretend that only its little world exists. But sometimes that's not sufficient. For example, you might have used the network host option, where you say, don't give me my own private network adapter. Instead, I want to use the host adapter. I don't want that sandboxing in that case. Bind mounts are very similar, where you're saying, actually, I need access to a host path. Take out that sandboxing and give it to me. So this is really, if we go back to containers as a kind of Linux kernel functionality, this is, you're kind of asking the kernel to set things up differently for your container to say, actually, let me go through. So, maybe another way of thinking about it is like a firewall, right? It's not an anti-pattern to allow things through your firewall. You shouldn't allow everything through, the same way that I wouldn't recommend bind mounting your slash, entire file system into a container. But when you want to open things up through, that's totally fine. So we got some fun spins. I hope you like it, because you're going to see more of them. So how do we actually use a bind mount on the command line? We have the short syntax. You've probably seen this before. -v, I have a host path, absolute path, colon, container path, absolute path inside the container, or actually will be relative to working directory, but let's say absolute. And then you can pass other options at the end. RO is a pretty common one you might see, which stands for read only. Now there is also the mount syntax. The mount syntax is functionally identical, but a little clearer, a little bit more readable. So I would particularly recommend, if you're writing a script maybe where you're doing something, prefer this. If you're doing a one-off on the command line, I'm not asking you to type all of this out. Go for the -v if it's more convenient for you. But it looks very similar. We have --mount. We've said the type is bind. We have a source. Again, that's the absolute host path. Target, that's the container path, same as before. And then options. Here, it's nicely spelled out as the word read only, so you don't have to guess at what that magic RO is. So here's an example of using it. We can Docker run, and here I'm actually bind mounting in the Docker API socket. So this actually allows me to use that Unix socket inside of my container to be able to control the Docker engine on my host. This is slightly distinct from Docker in Docker, because we're not actually running another copy of the daemon. We're instead saying, I want to be in a container, but I want to do things with other containers on the host. For example, if you've used a tool like Portainer, you're doing this because you're saying, I want to run Portainer in a container, but I want it to actually manage the entire engine. So I'm going to give it access to that socket. In my example here, I'm using the official Docker CLI image and running Docker Compose ls, which will give me any Compose projects running on my host. I'm not saying this is a great way to run Compose every day, but for example, in CI, you might see this as well. It's very common if you've ever used like GitLab runners as a hosted runner. You can set up Docker on the VM host and then have it provide access to that Docker socket to each running job. So it's a very powerful use of bind mounts. But they can also be used for normal files. So we have an example here. You might have seen the first one where we're using a subshell to run print working directory to get the absolute path. I've said absolute path several times. But then the second one there has a dot, which is the shorthand for current directory. So that's actually a pretty new addition in Moby 23. It now does allow you to use relative paths, which is very helpful, so you don't have to do the subshell, and you can just very quickly So my example here is I'm showing, hey, I've got my current directory. Maybe I'm working in a Git repo, and I want to mount that to the source directory in the container so that I can do something with it. And so again, if you're going to use a relative path here, the one caution I would give you is to really make sure that you always start with that // because the syntax can be ambiguous otherwise. So this is kind of a quick, very, very quick overview of how to use and run a bind mount to get a host path, again, into the container. So let's look at it again. Why might we do this? Well, like I keep saying, it's a little bit tautological. Maybe I want to allow the container to actually operate on files on my host. So more specifically, a common pattern, for example, is maybe you want to run a linter or a code formatter. Maybe I don't want to download that because I'm testing it out, or I'm using it as a CI pipeline. I could bind mount my working directory and then run that code formatter, let it write those files, and it's actually modifying the real files on my computer, not some files in the container, because we've mapped those together. So it's a really helpful way. There's a lot of utilities that use this pattern. On GitHub, you'll see, they'll say, hey, you can go through this complicated process to download and install, or run this nice little Docker run command and volume mount, or and bind mount and get everything. So that's a really great use for bind mounts. Also, just generally sharing data with an application on the host. Especially at Docker, we love to run everything in containers when possible. But in the real world, that's not always possible. You might have an application that you're not running in a container, but that still might mean that, again, you want as much possible as containerized. So let's say you have, a lab microscope that has a proprietary program, can only run, is not going to be friendly to be in a container, but maybe that program is outputting a lot of logs and files that you need. You could bind mount that for something like a Logstash agent to collect its logs and upload. So now we're getting this integration where I can use a container still how I want to use it to manage all of my parts, but I can still integrate with the rest of the system. I'm not restricted the same way, like I said before, you can use that network host when you want to use the host network. Oh my goodness. My thing is possessed. So it doesn't prevent you from doing that so that you can integrate nicely there. And then the example I showed before, again, it allows you to access the Docker engine socket from in a container. It's not exclusively the Docker engine socket. There's nothing special there. It's actually any Unix socket or any special files, because if you're familiar with the Unix POSIX model, there's always kind of the saying or joke that everything is a file, and that holds true here. This is, again, kind of a kernel level option to say, give me the raw access to this on the host. The same way you said, give me raw access to that network adapter, we're saying, give me raw access to these files, which might be special files like a Unix socket. And that will work to be able to get into the container. So it's another way of further integration and kind of being able to do some really cool things. You can also run, for example, Postgres, and many other tools can use Unix sockets, which can be more secure than using TCP because you don't need to worry about external access. You get to use all the great Unix permissions, depending on your thoughts on there. But it's a very, very powerful tool. But there are a few, I won't say downsides, but probably things to be aware of. So the first one that I would say is permissions and ownership issues. And really, this is not a problem with, it's not that bind mount is buggy or anything. This is actually what you're asking for. So if you've ever used a project and all of a sudden you've maybe tried to delete your node modules folder, not that anyone has ever needed to do that for any reason, but you might have all of a sudden said, oh, I can't because it's owned by root. Why is my node modules folder owned by root? You probably bind mounted it at some point. And when you ran that container as root, again, we exposed that directory directly to the container. The container was running as root. It wrote files. Those files are written as root. This is actually better in Docker Desktop if you're not using the engine on Linux, because Docker Desktop has a VM boundary and is able to do a lot of magic to help this and fix the permissions and make sure that things are correct so that you don't end up with a bunch of root files on your host. But again, it's something to be aware of and can be beneficial, right? Again, if maybe you're using Postgres in a container and you need to have it right on the host, you actually do want those files to be owned by that user. You don't want them to be remapped. But if it's not what you're expecting, it's very surprising and can be a little frustrating, especially for development. Additionally, it's not supported for Docker remote contexts. This is slightly inaccurate. They do work, just probably not how you're expecting. If I have my laptop and I'm using a remote Docker somewhere else and I do a bind mount, that path I give, that absolute host path, is not going to be a path on my laptop. It's going to be an absolute path on that remote server. So that you can use that, don't get me wrong, it's just probably not what you're expecting, because most of the time when you're running a Docker run command, you're thinking of the files on your computer and not a random path on a remote server. So once again, a little bit tricky there, and doesn't always work as easily as you might expect. And then I mentioned there was a bit with Docker Desktop. There's also potentially a downside, which is that there is that VM boundary. This is virtualized I/O. Now, I'm not going to stand up here and say that Docker Desktop has never had performance issues here. It absolutely has. We've made a ton of improvements here. Not me specifically, that's way too hard for me, but my colleagues have done a fantastic job. And there has been a lot of improvements here with things like virt.io FS. So if you think there's performance issues, try it again. Make sure you're using all the latest and greatest options in Docker Desktop. But at the end of the day, there's a boundary for anything, right? When we talk about distributed systems and scaling, if someone's telling you their system scales infinitely, they're lying to you, right? Everything hits a limit at some point. Virtualized I/O has a limit. So does your file system, the native I/O. There will be a limit, and that will be slightly lower. Figure out for your use case whether you're hitting that issue, whether you're hitting that boundary. But you'd probably be surprised that you might think my project is too big or won't work this way. It actually probably does, but in some cases it doesn't. So it's kind of the typical, you need to profile your application and understand, will these work in the way that I expect? So I'm not trying to scare you off of bind mounts, right? They're not an anti-pattern. They're great. They're incredibly powerful. They're just a little bit of a blunt instrument, because you're effectively saying, take this sandbox, this nice isolation that I had, and remove it, and then all of a sudden, you don't get to pretend that the world is as simple as you thought it was. You're now dealing with your host system, which is much more complex, and you have all the complexity that that brings with you, which is why we have volumes in Docker. So volumes manage the life cycle of persistent application data. So what I mean by this is, if we think of, often containers get described in sort of a cheeky way as being just processes with a bunch of fancy stuff on top. So if you want to think about that, then volumes are just a directory with a bunch of stuff on top. But the key part we're getting here is we're getting the same APIs that we have for containers for files, or for rather a location to store files. So we can create a volume and delete a volume and attach volumes to containers. And I say persistent because since the volume has its own life cycle, but it's a separate life cycle from a particular container. So I can create a volume to store my database data, create a container running Postgres, connect the two. Now I want to upgrade to a new patch version of Postgres. So I create a new container, but I don't lose all of my data because I still have that same volume that's attached. Now maybe later I'm developing and I say, hey, I want to reset my environment, so I'm going to delete that volume and get rid of all of the data. If you're using it in production, don't delete it unless it's backed up. But it gives you, again, that control with the Docker API, which is helpful because if we look at how you use them, there's our spin, we have very similar looking syntax here. I mentioned the ambiguous syntax before. You'll notice this looks very similar to what we had before. I have -v, but I have a volume name, not an absolute path, colon, that container path, and then the same thing, options. I'm showing read-only here. So that's why if you're using those relative paths with bind mounts, you need to be careful, because if you don't have that // it could be interpreted as a volume name and might not do what you're expecting. And so a great way to avoid that is use the more explicit syntax, because you can't get confusion here because we've told it that our mount type is volume, so it knows it's a volume. And again, very similar, we have our source name and our target path and then some options. So an example of how you might use this, kind of what I was alluding to before, I might create a volume to hold my database data, and then I could run a Postgres container, and I'm attaching that into the container so that now when that Postgres container writes to its var lib Postgres data directory, it's writing into that DB volume that I can attach to new containers in the future. It's also possible to use with compose. Bind mounts are as well. I didn't show it because I don't think they're as interesting. But for compose, we have here, again, two syntaxes, a little bit longer one, a little bit shorter one. Use what you want. I would kind of say maybe use the long one. characters are free in YAML. We don't get paid by the line, it turns out. So looks very similar. We've got the type volume, our name, and our target. And then the difference in Compose, though, is we actually, instead of having to run that Docker volume create, we have a volume section where we're saying, hey, I want a volume named DB. Under this, it's empty right now, but there's a bunch of other options we can put here. So now we get another benefit, whereas with a bind mount, we're just saying, give me access to this directory on the host. I don't know what it is. I can't control it. Here, when I can create a volume, I can give a bunch of options as well. I'm in control of both the life cycle and what type of options it's using. So, volumes. Like we said, you can manage them with the API, the CLI, or Compose. That's really powerful and awesome. They have high I/O performance. You don't have that, you never have to cross the VM boundary with volumes. If you're using Docker Desktop and you create a volume, those files actually exist inside of the Linux VM that it's managing for you. So we don't have to go across and we don't pay that overhead because we've allowed the engine and Docker Desktop to manage it for us. So by giving it control, we can get back and make sure that we have, I would say maybe more than high I/O performance, we also have consistent performance, right, across platforms. We don't have to worry about, am I on Linux or am I using Docker Desktop or this? We just kind of know that it works and it works the same everywhere. It can also support more advanced features like NFS and Samba. So that's why I was mentioning these options. I could actually have defined the volume there and said, hey, I want you to connect to a network share. So that's incredibly useful, especially if you're working with big files like AI models or other things where you have those already stored somewhere and you want to access them within a container. So you can now connect to a remote resource. And even more than that, there are volume plugins. So a popular one is SSHFS, where you can actually, again, with a custom plugin that you've installed to the Docker engine, you can now create volumes for other locations, such as using a mount over SSH. So that's, there's a lot of power and flexibility here. And really, the one big downside, I would say, of volumes is that you can't access them outside the container because we've put them in the container world. I mean, you can exec into the container and see them. Docker Desktop has really great tools to help you navigate and view them, but I can't just open Notepad and open a file because it doesn't exist on my host system. It's inside of a container abstracted away. So we've gotten a lot, but now we've made a slight trade-off here. So again, all of this is a balance, but volumes are the preferred way when you're managing persistent data with Docker to use, because we're now keeping everything nicely within that managed ecosystem where we're not just relying on a host path with the appropriate permissions and its own lifecycle that we don't know who else is on that system or anything. We can keep it all within the engine. And but we do have this slight trade-off that now everything is within Docker. So if we're outside of Docker, we can't really see it. Which brings us to Compose Watch. So Compose Watch keeps your development environment up to date while you code. Now, this definition is pretty substantially different than the other two. It doesn't actually sound like any kind of storage because, in fact, it is not. So we looked at those trade-offs there where we said, hey, bind mounts, it's very easy. I know I have a folder on my host. I have my Git repo that I've checked out. If I bind mount that, I can open it. I can look at it in Finder. I can do whatever I want with it. But I have all of these kind of slight trade-offs and maybe hiccups with actually using it. Whereas volumes, I get all these great things, but now suddenly I can't use my tools. I can't open IntelliJ and open the files in that volume because they're inside the container. There are, more and more tools like VS Code does a very good job of actually letting you, with dev containers as well, get in, but you're now choosing tools around the technology instead of choosing the technology that fits your tools. So with Compose Watch, we've designed it for hot reload in mind. Again, this is going to sound very different, and we're going to reconcile all this, don't worry. We're syncing from our machine to the container. So let's look at these two. We're trying to address the specific intersection of not limitations, but the trade-offs that have been made for both other storage technologies we have between bind mounts and volumes. They work well for their use cases, they work great, but for development, they just are not the right tool. So Compose Watch is a higher level abstraction. It is a feature of Docker Compose. It is not a feature of the engine itself. It's meant for development. It's meant for this use case. That's why we're focusing on things like hot reload or live update. There's a lot of great frameworks out there across JavaScript, PHP, Python, you name it, that are incredible, where you run one command and you make changes and you see them instantly. And we don't want you to lose that experience with a container. And bind mounts are often the way that you get there, but we saw some of the trade-offs already, and there's even a few other more subtleties we'll look at in a minute. And so again, it's this idea of we're syncing from our machine to the container, which is a little bit different because in a bind mount, everything is actually perfectly mirrored down to essentially the syscall level, you could say, right? So you always have, whether a process is looking at that file outside of the container or inside of the container, it's the same as two processes looking at the same file. Everything is transactional. Compose Watch is not attempting to do that. Compose Watch says you're working on code on your computer and you want to get that code into the container. Let's sync it over. Which gives us some benefits as well, right? We don't have to worry about if something happens in the container and files start getting deleted. We're not actually messing with our hosts. We're actually giving ourselves back some of that nice sandbox and isolation because now I'm working in my editor on my machine. I know what's happening here. Inside of the container I'm running where I'm putting files, if I'm debugging and I'm in there and I start running RM commands and doing crazy things trying to fix it, I don't have to worry. It's not going to touch my host. It's this nice one-way sync. It's non-blocking. This is sort of a similar thing. What I mentioned, bind mounts, you have this, you can run multiple processes doing extreme file level type of synchronization, and it's all going to work. But that comes with a cost, which is that virtualized I/O performance, for example, where it's blocking, because we need to make sure that that write completes and is seen correctly in the same way that every process, that an operating system expects to see that. This is more like a Google Drive or a Dropbox type model. So we can do it in the background. It doesn't need to block the write. When you hit save in your editor, there's not any delay introduced by this. It's not in the critical path anymore for the engine, which gives some benefits. And as I keep extolling, you get to use your own preferred tools because you're just looking at files on your laptop and they're being synchronized. There's no special tooling needed here to actually interact with these files. So again, Compose Watch is not the answer for everything. It's not write for write identical, sort of what I was mentioning before. And what I mean here specifically is not that you type in ABC and it's going to synchronize DEF into your container. That would be a little bit silly. I mean that if you make multiple changes in a row, for example, it might batch those together and synchronize them once. We see a lot with a lot of editors. If you use something like Procmon on Windows, attach to your editor and watch what happens at the file level. You would be surprised by, it's a very common pattern, for example, in the Unix world to make sure that you safely replace a file, to write a file with a new name and then rename it over the original file. What that means from, for example, like bind mount is you're seeing multiple writes all there happen in rapid succession, which can then slow things down and put more stress on your tools inside the container when they start trying to do multiple sequential updates in rapid succession that are unnecessary. Compose Watch doesn't have to worry about that. It can say, I'm going to batch, I'm going to debounce, because it has a high latency if you're a robot. As it turns out, as humans, when we type and do things, the amount of time it can take you to save and alt-tab to your browser or see the change, a few extra intentional milliseconds of delay here to batch and group things is not going to impact your experience. But if you were trying to do something high-frequency trading, you're not going to like this. But as a user, it's fine. We don't operate in terms of tens of milliseconds. So we can add a little bit of delay here to do these clever things that work for this specific use case, but that wouldn't be applicable in the general sense where we can't afford for something like Postgres to say, oh, write to the file, or SQLite, let's say, write to the file, and maybe we'll get around to synchronizing it, right? That doesn't quite work there. And lastly, it does require you writing a few lines of YAML because it's a compose feature. So once again, I think I mentioned before that I don't think any of us are getting paid by how many lines, by the number of lines that we write. So not that big of a downside, but I do know people have strong feelings about YAML. So that is a limitation here, or rather a requirement. So let's take a look at what a Compose Watch configuration looks like here. So I have a very small compose file here, intentionally overly simple so that it can fit on a slide and you can see it. I have a single service called web. We can assume it's sort of a front-endy Node.js type project. I'm going to have compose build it for me from the build context at the web directory. And then now I've added this develop key with a watch under it and a list of rules. So I have my first rule here is saying, hey, whenever anything within that web source folder changes, synchronize it into the container at the app source directory, which is different than we have to provide that binding so that compose knows where to take files and put it there. This is going to automatically respect our Docker ignore. So we're not going to pick up things that we don't want. We don't have to add other specific exclusions, for example. There's also, I mentioned that pattern of editors writing lots of temporary files. There's other hidden built-in, or not hidden, but built-in automatic rules to help prevent synchronizing files that we know are temporary files that are not useful, that you never would want into your container because they're going to exist for, again, a matter of milliseconds on your host machine before they get cleaned up by the tool. So we, because we're focused on development, can say we know what those are and we're just going to ignore them. And then I have a second rule here, which is actually saying when my package JSON file changes, we're going to rebuild. And that's because that's something where it's a little bit too complicated to handle synchronizing things over or doesn't make sense. And so this is the point at which you're saying, okay, this just, yes, you explained the downsides of bind mounts, but you also said, don't be afraid of the performance issues. And I'm using Docker Desktop, so it handles all the permissions issues for me. So why do I need to go through all of this? I can just bind mount my entire project. It's JavaScript, it's portable. JavaScript runs everywhere. You would be surprised. Your node modules folder has native code in there, especially when you're using tools like Webpack. They have their own file system watchers. So if I run npm install on my Mac, on my host, and then I go in the container and I synchronize and I bind mount that node modules folder in, it will error when I try and run because it's going to try and run a Darwin, a macOS binary inside Linux, or vice versa. If you try and bind mount it out and then run an npm install in Docker for consistency in that Linux container, if you're on Windows, you might get back Linux binaries on your Windows computer that are going to fail when you try and run. So even with interpreted frameworks, it's actually not safe to bind mount the entire project. And I say safe as in it's not going to work how you expect in all cases. Now, if you're only ever working on one side of the equation, on your host or in the container, that might not be an issue for you again. But this provides you, again, a nice high-level way to configure that and have these rules to say, I want my code in the container so I can use these frameworks, I can use this hot reload, and I don't have to worry about things like changes inside of the container messing with my Git repo on my laptop. It takes me a long time to write code. I don't want to lose it. And also, I don't have to worry about things like just all those different performance caveats because it's taking an entirely different approach that makes sense for this use case. And we think this use case is so important because we all want parity in our environments, right? And so the more that we can use containers and kind of what we call shift left and move and work within the container more and more as we're developing, the better it is. Because we can see those issues sooner. We don't have to worry about installing the right version of Node on our machine because it's just running in the container and we're editing a plain text file and synchronizing it in and letting everything else magically happen. So it's a very different specific use case, but one that is a use case that addresses what many of us spend a large portion of our day doing, which is writing code and getting feedback and getting that loop as fast as possible, but making it possible in a container. So don't use Compose Watch for a production service. You should not be using this as, when I say production, I mean like running in your customers are seeing, right? Not that, because you don't want to, this is a running process from Compose that is managing this. It's meant for developing while you're working to get your code in for hot reload. If you need to get files into a container in production, that's fine. This is not your tool for it, right? It's not what it's optimized for. It's not what's gonna give you the best experience. But it does also, again, for some of those limitations we saw before, one of the benefits here is that it does work with remote Docker instances as well. So you're not limited to local like you might be with bind mount. So that's another big, huge point of flexibility you get. Plus there's the fact that if you're already using Compose, once you put it in your Compose file here, now all of your teammates just have to run Compose watch and the project launches. It builds everything and it sets up these monitors so that now you can just open your IDE and code like you normally do and have everything happen, but be happening within the container. So it's a really great way to just kind of shift your development pattern, and avoid some of those limitations and pitfalls for, again, this specific development use case that we have with getting files across. And so we have a little bit of time, so I want to, if anyone has questions or wants to dive into any of these. I know that I talked a lot about Compose Watch towards the end because I want to make sure that that's kind of give you the clarification on why we're doing this and when it seems to overlap, because there is a lot of subtlety here with these, and it's not always the easiest to pick. But it does, you kind of look down. So I'm happy to talk also about volumes and bind mounts if you have questions about that. I'm not saying only ask about Compose Watch, but that's why we spent a little more time there, was to kind of help explain some of those differences.
How does Watch interact with copy?
So that's a great question. How does Watch interact with copy was the question. So a typical pattern that I would set up, if we're talking about a node, for example, a node JavaScript project, is in your Docker file, you would do a common pattern already for getting better caching is copy your package JSON or yarn lock, whichever file, in one step, and then run a download of those dependencies or an install, and then actually copy in all of your source code as well, and then have your command be your npm start or whatever your development command is. And that way when you run watch, it will get the copy of your repo as it is now, copy everything in, all of your source rather, so that it's consistent, and then from that point it will begin watching and start transferring the sort of the deltas based on your starting point as you make changes to files. So really you want to copy in all of your source code as part of the build so that it's already there in the container, and you actually have a functional standalone container even without watch, which is an important part here as well. We're not trying to fundamentally change what your container looks like. It's more of an additive piece on top, which is to say, we don't want to make you have to run a full container rebuild every time you edit a JavaScript file, because JavaScript has incredible frameworks out there that will do Delta updates and give you instant reload. So let's use that. So you build the container, everything's in it. It would work on its own if you didn't use watch, but watch will add this extra layer on for once it starts up. Now it will keep synchronizing changes as they come in without needing to do that full rebuild. Can you say that again?
Can you trigger rebuilds for other services?
Yeah, so yeah, the question is, can you trigger rebuilds for other services? So I have put my rules here on web. You can, every service, you can put watch rules on as few or as many services as you want. So if I wanted, for example, if I also had an API here, I would set up watch rules for that as well, and I could have a file where I would rebuild that. So I would define, as part of each service, you can define a rebuild rule for that, or multiple rebuild rules for that service.
I mean, like, can one service rebuild another? Like, we have a dependency.
No, yeah, not right now, but that's an interesting use case, and I would love to talk to you more after about it as well, so come find me. As we are looking, this is, these are things as well. This is, Compose Watch, also I will add, just went GA recently, right? So we have an initial set of functionality that we think is pretty powerful and works well, again, for the use cases that I keep reiterating of, like, kind of JavaScript type and PHP, similar other frameworks that are really amenable to this type of live update. We know that's not the only thing out there, and we know that just having a rule to say rebuild on any file change isn't particularly helpful in all cases. So there's a lot more possibilities out there. So we would love to hear, what you want to use watch for and how you want to do it. Yes, so the question is, when you do compose up, what happens with this section? So yes, this section is, the develop section is entirely ignored unless you're running the new compose watch command. That is the command that is using this section to, again, layer on top of your standard compose up configuration with these extra rules targeted specifically for development. And that's really the reason we put this under a develop section, because we're trying to really emphasize that we want to improve the development experience with compose because we know how much it's being used. So, but those tweaks and things you need for development are different from what you would need otherwise. If you're running in CI, for example, or integration tests, you might not want this. So it's kind of giving you a different layering and mode on top. But when you run an up, totally ignored. So the question is, could you also volume mount to the same path? So the answer is no. Right now, I believe, my colleague is shaking his head at me, I believe that it will give you a nice error if you try and do that, if you try and set up overlapping paths that wouldn't make sense, where you want to have a watch rule as well as something bound right there. And so that's also something, again, that we'd love feedback on of what makes sense there, right? Of, because there might be cases where you do want, in some instances, to have a volume or a bind mount at the same path where you want to do watch. So for right now, to avoid confusion, it will let you know, hey, you've kind of configured two competing things for this path, so you should pick one or the other. So the question, yeah, for your up, could you have a volume mount, but then for watch, could you use the watch mode? And yeah, so currently no, if that's the same path. So that is a limitation right now, that you would have a conflict kind of on that same target path. I will also give the shout out that we are at the Innovation Lounge for the, many of us will be there. Several people from the Compose team are there. We'd love to talk about this or anything else Compose related. And again, also, I love talking about anything else, Docker or containers or really anything, so you can just come talk to us and hang out. But we still have a few more minutes. There's other questions. I just wanted to make sure that I didn't forget. All right. Well, if there's no other questions, then thank you all so much for coming. I hope you learned a little bit, and I hope that if this is not the first time that you saw me talk today, that you're not completely sick of me. And if it was the first time, you still might be sick of me, and that's okay. And that's why all of my colleagues are giving, and many other people are giving some other fantastic talks that I hope you get to see and listen to. But thank you very much.